Hope I am audible here. Am I audible? Yeah. Am I audible? Hello.
Yes, sir. Yes, sir.
Yeah. Thank you so much. Sorry for the inconvenience. Yeah. So we'll continue. So here we have discussed about the sorting of plastic waste, and then this is one of the video you can go through by Stinert. The same what we have discussed, all the type of sorting of plastic waste were happening in a MRF facility that was projected in a video that you can go through the lecture and you can please go through this video also. Then different process of management of plastic waste. This is what we are going to discuss today. So
Excuse me. Actually, I am unable to see the slide.
yeah,
Is
yeah,
it
yeah,
happening to everyone or to?
yeah, yeah. I will share. I will share the screen. I forgot to share.
Yes. Yes.
Hope is visible now.
Yes, it's visible.
Yeah, this is the video I was talking about Stinert. Then this is what the four different process of management of plastic waste that we are going to discuss today to improve the efficiency of plastic waste management and to decrease the pollution due to plastic waste. These four different methods are mechanical recycling, feedstock recycling, energy recovery, and landfilling. So every time we have to think about what is the sustainable options. Like we have a waste management hierarchy. First we have to reuse. If something is produced, the waste is, if it is produced, then we have to look into how to reuse the same product in its original form. More than that is actually in 5 hour technique. Now we have 6 or 7 hour techniques. In that, first reduce scheme. Reduce is we can prevent producing the waste itself. If I want like want to buy a plastic water bottle, I mean mineral water can during my travel, I can avoid the waste by bringing my own water bottle to during travels. So that will reduce the production of waste itself. In the production line itself, it's starting the production of solid plastic waste. Then the second part will come in reuse. Reuse will be using the plastic in its same original form. Then third part will be reuse, reduce, then recycle. Recycle will give you a product that may having its original form. If I am recycling the plastic, then I will get a plastic polymer again. That plastic polymer will be used to manufacture plastic. So this kind of thing will called recycling. So without altering its original form or structure, reusing the same material in the production line, that is called recycling. Then third one is energy recovery. If I can't reuse the product in its original form, then I will dismantle, I will convert this product into a different form, and I will try to recover energy that is embodied in the product. So I will use plastic bags, I mean LDPE plastic covers and all in the incineration plant to recover energy. But no product will come out of it, but I can at least I can get the energy that is binded in the plastic waste. That is called energy recovery. So first reduce, then reuse. If reuse is not possible, recycle. If recycle is not possible, then go for recovery. That is energy recovery or material recovery. Here you can get at least ash. We will get that we can use as a use it for construction, building construction in concretes and the road laying. That ash and all will be a product recovery, and then energy recovery also is happening. So fifth part will be recovery. Then if nothing works, we have to go think about disposal. So disposal will be the end of tail end option. So that is like least favored option in the waste management hierarchy. Every time we have to think about more reuse, recycle, less disposal. So that is the waste management hierarchy we have to look on. But actually, what's happening is the what we call in the vice versa manner. Like disposal, we are doing more, and recycling and reuse, we are doing less. The hierarchy should be changed. Yeah, that's what we are going to discuss here also. First, we are trying for mechanical recycling. If mechanical recycling is not possible, then feedstock recycling, that is getting some product out of it. If product is not possible, then at least energy we are recovering. If nothing is possible, the plastic waste will go to landfilling as a final disposal option. So these are the four we are going to discuss, and its advantage and disadvantages. Yeah, here different types of mechanical recycling will be pelletization. In the if the plastic waste can be applied with some thermal energy to make it into a pellet. That pellet can be reused as a raw material for the production of plastic again. That is called pelletization. The extrusion, all the plastic will be waste will be fed into a hopper. That hopper will convey through a screw conveyor that finally will end up in a wire kind of structure. That wire we can cut into required somebody's joining. Yeah. So that wire we can cut into different sizes of pellets. That also we can use in the use as a raw material. That the same pellet can be used in the injection molding and drawing, shredding. This kind of plastic manufacturing techniques we can use for use as a mechanical recycling option. Then second one is the feedstock recycling. In feedstock recycling, we are using plastic to recover some solid or liquid or gaseous product out of the plastics. Like pyrolysis, we will get both the three fraction materials. Then gasification, we will get gas product. Then waste to fuel. Class point. Class class point. Record out. Yeah. Then energy recovery, we are using this plastic in the incineration or co-incineration plant to recover heat energy out of which. Then final will be landfilling, that is disposal option. First, we are looking about the recycling. Recycling, we can recover or reclaimed, reprocessed or refined to yield altered new product without changing the structure or in its original form. So that depends on the resin code. Whatever the PET type that if you recycle, that will again produce PET only. LDP means again it will produce LDP, yield LDP only. So the top priority of waste management will be recycling only. Reuse the waste productivity. Yeah. Here comes the mechanical recycling. Processing and conversion of waste or scrap into a product. Maintaining the original molecular structure of the material. Uh, we have some challenges in this recycling technique, like obstacles like low density of the material, and some of the recycled material will have lesser value. That we will call as downscaling. Downscaling means whatever the plastic bottle we are recycling, that can be used to make some low level materials only. We can't use the recycled plastic for again manufacturing the water bottles, because that may be harmful to the human health. So we do not use the recycled material for the production of same material in some places. So that again it's a downscaling option only. That are all challenges in the mechanical recycling. So this is the flow chart for mechanical recycling. First, the manual inspection for type of plastic, and then it will be different bulk materials also we can manually sort it out at the first stage itself, because this bulk material will damage the upcoming equipments. So the bulk materials we can manually segregate, and the remaining plastic will reach the washing plant. There the plastic will be washed because it's a waste, so it may contain some of the impurities. So that's washed by normal water. Then along with the water, the plastic may float at the top and the impurities may settle at the bottom. So this is the separation method, washing and flotation method. Then for getting the plastic alone, we have to dry it. At the top we can scrap the top plastic waste and we can dry the plastic waste alone. That will be going into the extruder at high pressure and temperature. I mean application of heat, it will be extruded into different wires. Then it is cut into a pellet kind of thing. So this pellet is we are using again in the manufacturing of plastic waste, manufacturing of plastic products. Yeah, that's what we have discussed in the first lecture. In the second lecture, again the mechanical recycling of plastic, same flow chart. Different plastic that is make into a, this is again a shredder that will make into a film or a particle will less than 5 centimeters of size, that will be added mixed with water to make it float at the top of the top surface. Then the impurities will settle at the bottom. Then the top one will be screened and it will be dried. Then it will be sent into the extruder at high temperature and pressure. Will get wire. That wire is cooled and cutting into different pellets. So this is the closed loop flowchart for mechanical recycling. What are the type of plastic that will be used for production of different product after recycling? If any waste is created, that can be collected by the municipality and it will reach the MRF facility. There by compression, it will reach the uh, because for transportation we need a reduced volume, so we will compress and the bales will be sent to this recycling plants. There it will be shredded, cleaned, and different types of flakes or pellets will be formed. If it that can be used in textile industry along with the raw cotton. It will be made into yarn and sieving. After sieving we can get again nowadays it's blooming plastic waste into t-shirts, plastic waste into sunglasses, like that. Different textile materials also coming up from the recycled plastic pellets. Then if you're seeing about sheeting, these pellets can be used for making sheets for fruit trays or by using vacuum molding. Then by injected molding we can get some stationary items or any types of toys we can get by injection molding. Then again the bottles we can make use of this pellets or plastic flakes. Yeah. What is the advantages of this mechanical recycling method? Because, we are applying more heat. So whatever the pathogen that is left along with the waste can be degraded at this high temperature, and also there is a reduction in the volume due to the high operating temperature. Whatever the volume required for recycling will be lower. By using produced gas as a fuel, one can able to limit the supply of external fuels. Yeah. Yes. So this mechanical recycling will have some disadvantages, like it will produce while heating some plastic may emit volatile organic carbons and a carbon emission that we have to take care, and it may have some health hazards that harmful to nearby plants and animal life. And as I have mentioned, this recycling will be again a downscaling option only. Whatever the product that is having less useful or having lower value than the actual metal. Anyway, it is recycled from waste only. So whatever we are getting will have a less value. For example, a plastic bottle might become a plastic furniture. In turn, there is still a demand to produce new plastic for the plastic bottle. The plastic bottle will become furniture, but to produce the plastic bottle for the future, we have a demand for fresh plastics. So we again will go for some production of plastic resins. So again this is a problem of recycling. Then the downscaling is the problem of recycling. Then it may not be durable. Whatever the product that is coming out of recycling will have a less durability. Then it is rarely suitable for second round of recycling. Then increased process cost. This type of everything will have some more energy intensive, more water intensive. Everything will add up the cost and low quality job. Yeah. Different types of plastic will have different capability of recycling. Only 8% of the plastic was recycled nowadays globally. In 1980s, if you see, 0% was recycled. At least we have reached the stage of 18% recycling. Still, we have 82% um, not collected and segregated properly, entered into the waste management system. So here if you see PET bottles HDPE are in this color denotes the easily recyclable items, whatever this PET and HDPE, and some are manageable like LDPE and PP are manageable. So if you add all this three, we'll get like 20, 40, 49, 59 percentage are recycled. So other after this 59, some of this like 40% in the other plastics and the PVC and the PS will have very difficult and difficult to recycle. Yeah. So what are the types? Will have this like credit cards, windows, door frames that are all made up of PVC. SDP will again have detergent, bleach bottles. PET bottles, as we know, all this cool drinks will be in the PET bottles. LDPE, all the carry bags and all. PP, food storage in containers. PS again, and then other will have different mixtures and multi-layered plastic will be in the others, like fabrics and all will come under others. This is called mechanical recycling. Here we got a product that have its original form again. But in feedstock recycling, conversion of plastic into a product that have unique properties, unlike the virgin plastic material. So it will undergo molecular and structural level changes. So here we have methods like gasification, pyrolysis, and waste to fuel that will break down the plastic and it will produce synthetic gas that is called syngas as well as other liquid and semi-liquid products. So if I break the molecules at high temperature more than 300 degrees Celsius, that is called the pyrolysis technique. At that temperature, the plastic will undergo in the absence of oxygen molecular degradation, and the product called biochar will be obtained as a solid product, and then syngas will be the gaseous product, and some liquid that is called a pyro oil as a liquid product. So all these three type of products we can be yielded by pyrolysis method, but nothing will be in its original form like the plastic. Yeah, that's called the pyrolysis of plastic waste. This is the endothermic irreversible thermochemical degradation process of decomposition of complex long chain organic polymer into simple short chain polymers at the temperature greater than 300 degrees Celsius in the absence of atmospheric oxygen. That is again important. In the absence of oxygen, it is called pyrolysis. If it is in the presence of oxygen, that is called incineration. Yeah. So pyrolysis of plastic waste involves breaking down a plastic product into all the three phases. That is the product, solid, liquid, and gas. Solid product will yield char. Liquid product will yield oil-like material similar to diesel. The gaseous product will yield syngas, that is the synthetic gas, and it is having a good calorific value. This synthetic oil can be uh, used as a fuel. Yeah. Yes. So this is the flowchart for a pyrolysis process. Initially, it is a feeder and it is having a drying unit because we are if moisture content is there, again it will increase the energy consumption for heating. Because it is the endothermic process. We have to apply heat to make these products. So it is the energy consumption process. Exothermic means energy releasing. Endothermic means energy absorbing process. So pyrolysis is an energy absorbing process. Incineration is an exothermic energy recovery process. So here if moisture content is present in waste, that will decrease the calorific value and that will increase the energy consumption. So we are having a drying unit and a compacting unit that will increase the density of waste, and it can be the dense pellets are given as a feed to the pyrolysis chamber. So this is the pyrolysis chamber at high temperature, like more than 300 degrees Celsius. It will go up to 800 also. So at that temperature, we can get solid char, that is biochar. Then we can get the gas will go into this pipeline. That will be condensed. D is the condenser. So we will get liquid oil at the gas from the pyrolysis plant. Then the remaining gas will go into E, that is gaseous emission. Sorry, E will be the air pollution control unit. Air pollution after removing all the hazardous waste like dust particles and the particulate matter, syngas will be collected as a product. Yeah, J will be nitrogen purging because this combustion is happening in the absence of oxygen. So we have to give nitrogen. Nitrogen we have to purge as a we have to maintain some environment. So we are purging nitrogen as a this is happening in the nitrogen environment. Yeah. So this is the whole process of pyrolysis. Feed is coming, moisture removal by drying, then compaction. The compacted dense fuel is inserted into the pyrolysis chamber, and with the supply of nitrogen, combustion at high temperature, it will produce char. Then the gas will be condensed to get liquid. Then the remaining gas will be filtered with the air pollution control system, and the gas is collected as a final product. This is also another video that you can go through for plastic pyrolysis process. The same what we have discussed in an actual form. Yeah. So what are the advantages of pyrolysis? This recycling of plastic waste, because in normal recycling like extrusion or whatever recycling that I have discussed earlier, that need sorting of plastic waste into based on its form. If I want to give a if I want to extrude sorry for the background noise. I am in a conference hall that we are arranging. Sorry for that. Yeah. So if you want to use recover plastic through mechanical recycling, then it will have a it should be sorted properly. LDPE means LDPE we can recycle. HDPE means HDPE we can recycle. But Mixed plastic cannot be recycled by mechanical recycling method. But in pyrolysis, all the mixed plastic can be given as a feed to the pyrolysis chamber, along with some of the impurities which is present that can be recovered in the biochar. So whatever unwashed, whatever mixed plastic, whatever soiled plastic that we can give as a feed to the pyrolysis plant. Yeah. So that are all advantages of pyrolysis of plastics. The recycling of plastic, some plastic cannot be mechanically recycled like PVC that will have produce harmful gases. But here you can use plastic laminates, co-extrusion, multi-layer packaging, everything you can give as a feed to the pyrolysis plant. That is one of the advantage. But coming to the disadvantage, it is a complex process and a high operational and investment cost because we are giving energy greater than 800 degrees Celsius that will be energy intensive process. Again, add to cost for your recycling process, and then the air purification installation required. Mechanical recycling, there is no requirement of any air purification system. But pyrolysis and incineration plant require air pollution monitoring and control systems. Then whatever the ashes produced, that whatever the char we have discussed, a solid product that will have high heavy metal contamination. So this contamination cannot be removed. That will again impart some treatment technology, cost energy intensive process, and it is a non-continuous batch process, not commercially viable. So, if you think about incineration, that is a continuous process. Whatever the waste is coming, that we can give as a feed. But pyrolysis is not a continuous process. We can give as a non-continuous batch process. One batch we can send, we can get the product. Then after some time, second batch can be sent. So this is a non-continuous batch process. Yeah. Some other disadvantages like coking and carbon deposits on the heat exchangers. Whatever the ashes, fine flying ashes that may be deposited on the surface of the pyrolysis chamber, and it will again damages the surface. So it won't be any heat exchange. It will affect the heat exchange property of the surface. Then sticking of sand particle in the fluidized bed processes. Yeah. So the third option is incineration. Incineration is total burning in the presence of oxygen. So burning waste product in the presence of oxygen in excess amount by thermal degradation. So again here also the chemical reaction is happening, and all the product what we are getting will be different from the plastic product. With whatever the inlet plastic, and only ash as a product. There is no syngas. There is no pyro oil will be the product in the incineration, but we can get the energy from the incineration process. Pyrolysis is endothermic, that we have to provide energy, but in incineration exothermic, the burning of plastic waste will give you energy. By burning plastic waste we will get energy that can, I mean heat. That heat will be used to boil the water. Then the stream will be transported to run the turbine. Then electricity will be produced from the turbine. So this is the process of incineration to recover energy from the plastic waste. Here the temperature will go from 900 to 1100 degrees Celsius also by proper combustion. Here we need three major parameters need to be optimized. One is temperature, another one is turbulence, the time and the flow of air. Sorry, actually four parameters, three T we will call. So temperature should be maintained 900 to 1100 degrees Celsius. For that, whatever the fuel required, we have to give. Plastic we have to always feed. This is a continuous process. The turbulence we have to make. This should be always in the motion. The time we have to manage, how much time it should be in the incineration plant, and the flow of oxygen should be maintained properly. Otherwise, some incomplete combustion will happen and the product will not be perfect. Sorry, the process will not be perfect. So incineration is a new sorry, whatever the new technology that have developed, but they are complicated and costly, which is the problem of for a developing country to execute as they lack the internal technical expertise to overcome them, for which it leads to the project failure. That's why always we are not in India we are having only three incineration plant, that is waste to energy plant, that is also not in operation condition. Two are in Delhi. You can think search about Okla waste to energy plant, like that. Another two are there. All these are shut down in shutdown condition now, because we can't expect continuous flow of plastic waste as a feed to the incineration plant. But in abroad, if you think most of the composition of the plastic, municipal solid waste will be paper, plastic, rubber, tires. These are all combustible materials. So they will operate the incineration plant. But in Indian scenario, most of our waste are wet waste, and we will have less plastic and paper in the composition of municipal solid waste. That's why this type of projects will be failure in Indian subtropical subcontinent. So we have to think about the tropical condition. We have to think about the composition of the waste before designing any incineration plant, and we have to analyze the feasibility and suitability of the technology for a country. We can't use the technology that is following in different countries in India. That's the problem. Okay. Yeah. So here we need equipment like pre-treatment, combustion system, energy recovery system, flue gas cleaning systems. Yeah.
It is very difficult to hear. You cannot change the place.
1 second, madam. I'll try to. I'll try to.
Very hard, difficult to hear actually.
Yeah, I'll try to change the. Yeah. I hope you can hear me now. Is it fine now, ma'am?
Yes, it's okay.
Yeah. Sorry for that today. I'm so sorry. We'll continue the lecture. Yeah, in waste to energy plant we have like it's the incineration plant, or any you can call as a waste to energy plant. Here a bunker, so the waste will be disposed in the bunker, garbage bunker. Then a crane will be taking this garbage from the bunker to kiln. Kiln is like a oven. So here we are maintaining, we are giving a air supply, and we are maintaining the temperature at 1100 degrees Celsius to incinerate the waste, whatever the waste that is coming in. And then it can be the whatever the steam heat that is produced will be sent to the boil, that will be absorbed by the boiler, and the water inside the boiler will be heated up, and the steam will be produced. That steam will run the turbine, and the energy will be produced as a final product. So this is only the energy recovery process, but we'll get mostly air pollutants here. So we should have a proper air pollution control and management system. So this is a fabric filter reactor, and again a fabric filter to control all the particulate matter, H2S gas, whatever the harmful gases that is coming out of the incineration plant. It should be filtered before sending out into the atmosphere. Yeah. So you can see a video in this. You can refer the lecture for some of the videos, or you can simply go through YouTube videos like waste to energy plant, pyrolysis plant, incineration plant, mechanical recycling of plastic. You'll get a number of videos. Yeah. So advantage of incineration will be we can get high calorific value, produces high amount of energy. Whatever because plastic and papers have high calorific value, so it will be more suitable as a feed for waste to energy plant, having high, it produces high amount of energy. Then CO2 and other oxides are produced by the thermal decomposition of organic matter, and energy can be recaptured. Then generation of power, substitute of fossil fuels, and it is the exothermic process. If it is an endothermic process, that will we need to give supply energy, but it is the exothermic process that will produce energy, and the volume of waste is reduced by the incineration plant. In addition to the burning, high temperature environment will lead to decomposition of toxic elements. That's what we have discussed in the mechanical recycling also. Whatever the high temperature we are giving or it's producing, that will give what that will destroy the pathogens or any toxic component that is present in the plastic waste. Yeah. Disadvantages will be producing toxic gases when burnt. That is one disadvantage. That if, for example, if you see styrene, styrene will be a toxic compound that will be produced when you burn polystyrene, and this will be having some health hazards like blindness, vomiting, and other symptoms of inhalation. Then PVC if you burn, that will have hydrogen chloride gas, H2S gas as a sorry, uh, hydrogen chloride gas as a product. Then this incineration process is again more expensive, like operation cost also expensive, and setup costs, that is capital cost also it's expensive. It requires a skilled labor, and the process demands continuous supply of waste. So here I have red marked that that's the major thing we have to discuss, whether we can be able to supply waste continuously throughout the year or throughout the operational period of the waste to energy plant. Otherwise, the waste to energy plant become a failure model. Yeah. So here the final option will be landfilling. This is old method. Before plastic come into picture, before the industrial era, we can see whatever the waste we are generating will be biodegradable. So whatever we are dumping in the dump sites, that will degrade on its own, and it won't consume lot of land. But if after plastic come into picture, this is whatever the waste disposed in the landfill, the plastic will be ideal, and it is plastic will be ideal, and it is consuming lots of space. So we need to think about, we should not need to think about landfilling. Landfilling is not simple dumping as it's happening in India. Landfill is a scientific engineered concept. We have to have a liner system, we have to have a uh, covering system, gas extraction system, leachate monitoring, and leachate monitoring system, and every day we have to have a cell and cell cover, daily cover. This type of scientific method is called landfilling. But what we are doing in India is called normal open dumping. We don't have any scientific landfill in India. That is one another disadvantage. So it is having a problem like aesthetic and visual disturbance. It will generate leachate. Again, it will damage so pollute the surface and the groundwater. Yeah, this is what we are talking about, the engineered landfill. So we have to dig, or we can have surface landfilling or deep surface landfilling, like below ground landfilling we will call. First, we have to have a plastic liner. Plastic liner will be used to prevent leachate entering into the leachate entering into the subsurface. So for after landfill liner, we have to have a clay liner, that is compacted clay, which is having a permeability less than 10 to power minus 7 meter per second. That much low permeable clay liner we have to have to a thickness of 1 meter or 2 feet. That much thickness clay liner should be there. Above that, we have to have a pipeline for leachate collection. Then waste will be deposited every day in a cell manner. That waste can be covered by every day we have to have a cell cover. Then finally, after the landfill reaches its full capacity, it should be covered with the full cover with again a clay liner and a plastic liner, again a clay liner with the vegetative cover. That is, we can grow grass, or we can make it into a park, which will reduce the infiltration of rainwater into the landfill, and it will reduce the production of leachate. Yeah, these are all the whole concept behind landfilling, engineered landfilling. And whatever the leachate collected through this pipe, that can be transported to the leachate treatment plant that is constructed near the landfills. And whatever the gas, because if this is anaerobic condition, we are closed environment. So whatever the gas produced, that will have a methane. So we have to have a energy, sorry, gas collection system that can be used to recover energy out of it. Yeah. So we have to have a proper monitoring system of groundwater. Before and after land, some 1 kilometer behind a landfill, we have to take a we have to have a monitoring well. And after the landfill, we have to have a monitoring well. Both the quality we have to check to note down any contamination happened. Any contamination due to infiltration of leachate may happen or not, that we have to check. But we have some advantage for landfill, like this cheapest, easiest option, because transporting the waste to the nearby site and just dumping in the open land, that is called the cheapest and easiest option. And it requires no technical knowledge, just a less expertise required. Carbon sequestration, aesthetic and environmental acceptable solution if properly managed. Not open dumping. environment landfill will be engineered landfill will be aesthetically and environmentally acceptable. And engineered landfills are always better option than irregular disposal and uncontrolled body of plastic waste. But the disadvantages are more for landfills. Like it's uh, plastic waste will be of low density, will consume lots of space, and it is very difficult to pack because low density will consume lots of space. Volume will be more, and it's having low biodegradability. After 50 years, also, if you dig the landfill again, the plastic will be ideal as it is, and it is hampering due to the presence of plastic in the landfill. It will hamper the growth of plant in the nearby areas, and the productive liner what we have used at the bottom will have some rupture and leakage. Again, leachate will enter into the groundwater, and it is having a risk of soil and groundwater contamination, irrecoverable land loss, and it will. So we have to consider landfill as a humble last disposal option. That's what we can say. If nothing is available, we can't reuse, we can't recycle, if we can't recover any energy, then the final option for inerts we can think about landfill. For plastic, we should not even think about landfill as a option for management. Yeah. Again, landfill. Yeah. So this is what we have. This is the comprehensive slide what we have discussed earlier. So in mechanical recycling, sortation, flotation, micro sortation, solvent separation are there. That is cost effective and all. Then reduce the GHG emission, saves energy, conservation of material. And then feedstock recycling, we have discussed about pyrolysis, co-pyrolysis. Co-pyrolysis, co-pyrolysis or co-incineration. Wherever this co comes, we are incinerating or we are making plastic as a feed along with the other fuels like wood, agricultural waste. These are all we are giving as a co-fuel. So plastic is adding combustion value to it. That is called co-fuel. If you are only using plastic, then it is pyrolysis and incineration. Yeah. So some of the environmental and economical aspects were discussed in different colors. Yeah. So these are two methods of loop, a circular economy loop. Here in the consumers, we are generating waste. That waste is transported and it was transported to the incineration plant. Incineration, we are boiling the water and getting running the turbine, and the electricity will be produced. That electricity we are using again in the consumer's home. If we discard any plastic, that plastic is going to recycling facility, and after recycling, shredding, washing, that can be manufactured into any new material that again reaching the consumer. So this is called a circular economy closed loop system. Yeah, this is Plasticos. This is a company uses plastic waste in the block manufacturing. These are all plastic blocks that can be used in the building, used as a building material. So every year 700 tons of plastic is discarded. Sorry, every day discarded. Uh, So the company called the Conceptos Plasticos transforms plastic and rubber waste into construction material. Yeah, you can see the house they have built in a video that I will that I have shown. Then recycling plastic waste into power blocks also we can make. Whatever the power blocks are a building blocks that we can because plastic is having good melting point and good binding capacity, so we can convert it into any product that can be used for human applications if it is in a good sorted form. This is a building constructed using recycled plastics. So co-processing of plastic waste in cement kilns, that is one another option. If it is a non-usable heterogeneous mixed kind of plastic waste, then we can think about plastic waste incineration in the cement plants. Instead of normal incineration and the waste to energy plants, we can use plastic waste in the cement plants. Because anyway, cement production, if you are a civil engineer, you know how the cement is manufactured in the industry, how much fuel, I mean coal is used, because one of the uh, most which method produces releases most CO2 into the environment is cement production. So that's the major area we are now thinking of sustainability. So we are using instead of coal whatever sustainable alternatives we can use to reduce the consumption of raw fuel. Like plastic can be used as an alternate fuel, alternate and raw material, AFR we can say, alternate fuel and raw material as a in the cement plants. So that will eliminate the need of investment on other plastic practices. Yeah. So we can use the plastic in main burner at the rotary kilns outlet, the rotary kiln inlet. then the pre-calcinator, and the mid kiln also. Everywhere you can use this type of plastic waste as a fuel. So we need energy in different parts in the cement production. Like raw material, clay and stone will come. Then stockyard, we drying mill, preheating, burning, and clinkers will be formed. This is the cement manufacturing process. Lime and clay will be added along with the silicon, and it will be heated at high temperature to produce cement clinkers that will be grinded into cement powder. So this is the process. Here everywhere we need high temperature, around 1500 degrees we required. So everywhere we can give plastic waste as a input in the cement kilns. This is a new concept. Use of plastic in road making. The road construction using plastic waste are popular nowadays. Not only nowadays, 90s itself it has started. 1990s and 2000 and all. It's blooming plastic in the road because we are using bitumen for the road construction. If you are a civil engineer, you know in transportation engineering you have studied about how the road was constructed, bitumen roads and the concrete roads that is flexible at the yeah, you have studied about this bitumen pavements and the concrete pavements, and the plastic roads will be used along with plastic will be used along with the bitumen to increase its melting point. Yeah, it will perform better, and it will you can reduce the crackage and shrinkage, potholes, this type of road issues you can eliminate. So plastic carry bags, disposable cups, pet bottles, this type of plastics can be used. Like thermoplastic we can use for plastic roads. Thermosets we can't use. So this is the important ingredients for the construction material. When mixed with the hot bitumen, plastic melt to form a oily coat over the aggregate. Here you can see it will have a durability, high durability and corrosion resistant, good binder, economical and longer life, because instead of bitumen you can use plastic that again reduce the cost. Waste you are utilizing in the construction material. Then ease of processing, installation, lightweight, and its improve aggregates impact value, increases melting point of the bitumen. Yeah. Now, what are the type of plastic that we can use? What are the type we should not use? So in road construction, we can use film like polyethylene films, PPS. We can use hard foams thickness, hard foams of any thickness, soft foams of any thickness, that is PP and PE. Then laminated plastic up to 60 micron. These are all we can use. Okay, but we should not use PVC sheets and the flex sheets in the road construction. These are all thermosets again. Yeah. So this is the basic process of road making from plastics. Like we have to segregate the plastic, we have to clean, we have to shred, and this should be transported. Yeah. One second. Oh, okay, okay. So, So we have two processes of plastic road making. One is dry process, one is wet process. In dry process, we are heating up to 170 degrees Celsius, but in wet process, we are adding. Sorry, we are mixing at 160 degrees Celsius, and it requires lot of investment and bigger plants like addition of stabilizers, proper cooling techniques are required for wet process of plastic manufacturing, and then mechanical steering also required. Yeah. So here you can see different plastic roads, road layings. Uh, uh, this road is laid from plastic waste at 120 degrees Celsius. Aggregate we are heating at 120 degrees Celsius. Then plastic coated aggregates are there. Plastic coated aggregate mixture. Then road laying at 120 degrees Celsius. Yeah. So plastic is a good binder and it improves the impact strength and it increases the melting point of the bitumen and it improves the improve the quality of the flexible garment. If you see with compare with the normal bitumen road, it will have a deformation, cracking, and potholes. If you see in the plastic roads, no edge flaws, no potholes, no deformation, and no cracking. Yeah. What are the challenges is commingled plastic like heterogeneous plastic will we can use in the cement plants. Yeah, and it has a presence of toxic HCl gas, and the plastic can be break down into microplastic. If you use in the road, due to the movement of vehicles, due to wear and tear, some plastic particles may enter into the environment as a microplastic, and it microplastic will also absorb other pollutants, and it requires use of compatible plastic. Different types of structural weakness and premature failures may also happen. So there are all the different types of advantages that I have discussed earlier: increased stability, better resistance, no stripping, increased binding, poor reduction, no effect on UV radiations. The strength of road will be increasing by 100%. Again, whatever the bitumen's road strength, it will again increase by 100%. The load is withstanding properly. For increases the load withstand capacity, then 1 ton of bitumen uh, will be saved if you use 1 ton of plastic. That is again, if you think about the cost, it will be reduced because we are using waste as the raw material. And maintenance cost will be nil, and disposal of plastic waste no longer be a problem. But the disadvantages is the toxic element may leach out after laying the roads, and due to presence of chlorine at high temperature, toxic HCl gas may be released, and in the first rain after the laying, it may be the road may be sticky. Yeah. So these are all some of the government project, and the government mandates the use of plastic in the road manufacturing. Yeah, this is another court order that considering the plastic waste in the road construction in Himachal Pradesh. Yeah, here comes the microplastic problem. Conventional, whatever that water treatment plant we are having, not having system for microplastic removal. But even though our system like filters and sedimentation tank will remove some of the microplastic, somewhat efficient we are getting up to 80% and 70% microplastic removal we are getting. Still 30% and 30 to 20% will reach the environment through effluent. Yeah, and it will create some health hazards like specific tertiary treatment for microplastics are disk filters, rapid sand filter, dissolved air flotation will float the microplastic to the top of the water surface, and then membrane bioreactor that will again filter out the microplastics. Yeah, and this, all the airports will have to use plastic waste for runway constructions and all. This are all still we are having. Chennai, if you see, go to Chennai airport, you can see runway made out of plastic waste. Yeah. So again in Bengaluru, if you see 600 kilometers of roads are made with plastics and 25 percentage least road laying work. Then plastic model will be adapted in all this type of roads in Bengaluru. Yeah, you can see some of the photos of implementation. In the conclusion note, we can say waste plastic is increasing now every day, but use of waste plastic for permanent is one of the best method and easy way to dispose the plastic waste. And we have mechanical recycling, feedstock recycling, incineration, and landfilling options as a least preferred options. And we have a mood for India's hot and extremely humid climate that may cross above 50 degrees Celsius, and some of the climatic conditions like heavy rain may hinder the plastic roads. But still it's a economical friendly option for the disposal of plastic waste. Yeah, that's what this week's content will go to the question answer session. Yeah, hope the screen is visible. And yeah, can you one second? Yeah, can you post the answers in the chat box, please? The first question is, which sorting process of plastic waste uses centrifugal force of separation? Density sorting, heavy medium separation, hydrocyclones, triboelectric separation. Yes, it's the yeah, it's hydrocyclones because density sorting is simply by air blowing HDP LDP can be separated. Heavy medium is use of high dense liquid. Hydrocyclone uses water to wash away the triboelectric separation. Yes. So this is a hydroelectric cyclones uses centrifugal force that enables the recombination. Second question is, what is the correct sequence in mechanical recycling? Chopping and washing, separation by flotation, drying, inspection. How to arrange? First, what we have to do? So the first will be manual inspection. First will be manual inspection, correct. Then, so before, after washing, drying should be there. Washing, then flotation, then drying. Yeah. So B is the correct answer. Yes, correct. First, we have to manually inspect if any impurities is there or not. Then chopping and washing with water. Then the floating plastic waste is separated. That is dried and used for recycling. Yeah, B is correct. So, what is the disadvantage of mechanical recycling? The use of high temperature degrades the toxic compounds and pathogens. There is also a reduction in water volume due to high operating temperature. Recycling plastic can produce VOC and carbon emission into the atmosphere. One can limit the supply of external fuel by reducing the using the produced gas as a fuel. Yeah. What are the disadvantage? Yes. C is correct. Yes. So others are some of the advantages. Recycling plastic can produce volatile organic carbon and carbon emission. Uh, yeah. C is correct option. Yes. Yeah, fourth question is, during which type of plastic recycling process does the plastic undergo molecular and structural changes to produce product with unique properties, unlike the raw material? So if it is having the same property of raw material, then it is called mechanical recycling. If it is having unique property, then it is called yeah, feedstock recycling. That is correct. Yes. But in incineration also, there is no product, only energy recovery. Yeah. Okay, moving on to the first question. The basic process of laying of plastic road that we have discussed now 5 minutes back. Segregation, shredding, cleaning, or how to arrange. First, segregation. Yes, segregation, then cleaning, then shredding. Because after cleaning, how to segregate? So first segregation, then cleaning, or shredding and collection. Yes. Sixth question. The German Thermal degradation of plastic waste with continuous oxygen supply is called. With the oxygen supply. Yeah, that's correct. So with oxygen supply, that's called incineration. Without oxygen supply, that is pyrolysis. Then burning of waste plastic will produce toxic hydrogen chloride. Which type of plastic? LDP, PVC, HDPE, PET. Yes, because PVC having chlorine in its name itself, so PVC is the correct answer. Yes. Then what is the benefit of using plastic for road making? Benefits of using plastic in the road making. Yeah, that is correct. Reduction in pores in aggregates and less rutting and travel. Yeah. அண்ணா நான் உள்ள உட்காரலாங்களா ஒரு 5 minutes. Yeah. Here again statement question. The first statement is any waste plastic can be used in pavement construction. Second statement is only waste thermoplastic can be used in pavement construction. What will the answer? Any plastic can be used in the pavement construction or only waste thermoplastic can be used in the pavement construction. So option C or D. Yeah, D is correct. False. I mean, first statement is false. Second statement is true. That's correct. So only the type of plastic like film up to 60 micron thickness, hard foam, soft foams, laminated plastics that can be used. PVC and flex sheet cannot be used. Yeah. So then the substitution of coal by plastic waste as a fuel is called. Substitution of coal by plastic as a fuel is called. Landfilling, dumping, recycling, co-processing. Yeah, the answer is co-processing. Correct. Whatever we are mixing along with the plastic and using as fuel, then it is called co-processing. So true or false question. Using plastic may increase the cost of road construction. True or false? Use of plastic increase or decrease the cost of construction? Increase, given it is increase. A or B? Yeah, it's false. Correct. So plastic, because plastic is the waste that we are using in the road construction, so it will reduce the raw material cost. So its answer is false. Then question 12. Landfilling of plastic waste is considered a humble last disposal option as it is the cheapest and easiest management option. True or false? Cheapest and if it is the engineered landfill, sorry, open dumping, it's the cheapest and easiest option and it is a humble last way of disposal. So it's correct. True. 13th question. Select the false statement related to incineration. Incineration process reduces the volume of waste. A large amount of ash is generated from the incineration plant. Unskilled labor is enough to maintain the incineration plant. Power can be generated from the incineration of plastics. So it may be multiple option question. False statements. What are the false statements? Power can be generated is true. Incineration reduces the volume is true. The large amount of ash is wrong. Unskilled labor also wrong. because already it reduces of most of the volume. So whatever the ash produced is only 1%. If you burn 100 kg of waste, only 1 kg of ash you will get. So amount of ash will be less, and unskilled labors are not skilled labors are required for incineration. Yeah, so both are false statements. Then moving on to 14th question. Pyrolysis of plastic waste involves breaking the plastic into product of all three products: solid, liquid, and gas. Breaking of plastic into three products, three phases of products. True or false? Yeah, true, correct. An air purification installation is unnecessary to treat flue gases from waste pyrolysis. True or false? So air purification is required for incineration, and both pyrolysis and incineration requires air purification system. So here is mentioned as unnecessary, so it's false. Yeah. Then what we have? Again in 2020 questions same have repeated lost. One or two questions are different. I will go directly to the same question. Here the sorting process of plastic waste centrifugal waste uses centrifugal force. Yeah, it's hydrocyclones, correct. So that's the water intensive process, hydrocyclones. Not B. B is heavy medium separation that uses density dense liquids. Then correct sequence in the mechanical recycling. It's we have already discussed inspection, shopping, separation, then drying. Yeah, and we have discussed. Which requires continuous supply of oxygen. What we have discussed is which does not require continuous supply of oxygen. That is, I mean, not absence of oxygen pyrolysis. Continuous supply of oxygen, it will be incineration. Yeah. Most are already disclosed. Yeah, this is a new question. Which type of plastic is not used in the road construction? Not used. So whatever the type we have discussed,
Excuse me.
yeah.
What is exactly flock seed?
What is exactly
Flock seed.
flux sheet? It's it's a sheet, banner sheets and all, you know, Naman. Banners and all, that will be the flux sheet, like a polysters.
Which one?
Banners and all flux, you know,
No, polyester or something like that.
polysters. Yeah,
Okay.
and some. Uh, I'll give you some examples in the next class. I'll post in that discussion forum also. Flux sheet
Okay.
examples. Yeah, I'll give you some
Okay.
images. Yes. So here PVC and flux sheets cannot be recycled. Yeah. Then so okay here. Which of the following is not a feed point for plastic waste material into the cement plant? Not a feed point. So we have given feed point at main burner, rotary kiln inlet, pre-calcinator we can use, but in the clinkers we should not use. Clinker is a product in the cement plant. Yeah, this is all we have discussed. Yeah, volume of waste is reduced by incineration plant. That is true. Only 1% will be a ash. Another 99% will be recovered as energy. I mean, it's combusted. So here it's a tricky question. Pyrolysis is an endothermic process, irreversible thermochemical degradation. Kindly look into each and every word. Decomposition of complex long chain polymer, molecular into unit, long chain polymer molecule into simpler short chain compounds at a high temperature greater than 300 degrees Celsius in the absence of atmospheric temperature, with or without the application of pressure. Pyrolysis of plastic involves breaking down into products of three phases. It is true or false. So it's true. Yeah. But the same if it is mentioned in the incineration. Incineration in the absence of oxygen, that is false. Incineration requires continuous supply of oxygen. And air purification system is not as yeah, it's we have discussed it. It's false. Yeah. So kindly go through today's I mean this week's assignment session for week 6. Tomorrow is the deadline, and we have a live session with the Professor Dubey sir. Kindly check your mail, and the date is I guess 7th of March. I guess kindly look into the mail again. And if you have any doubts, kindly post it in the discussion forums, or you can unmute and ask now, or you can ask me anytime through this mail ID. And if you have more doubts, you can directly come to the live session for Professor's live session, and we can discuss. Yeah. Thank you so much for your patience, and sorry for the technical glitch and sound background noise today. I'm so sorry for this. Yeah. Thank you so much. If you have no doubts, you can leave the meet. Yeah. Yes. Okay, I'm closing the meeting. Thank you so much.